Today we will discuss parameter and interval estimation. Okay, so we will discuss your parameter versus statistic, a discussion on what is a parameter and what is a statistic, and we will discuss interval estimation of your population mean, proportion, variance, and ratio of two variances. In the process of discussion of the interval estimation, we will mention the importance of your confidence interval and how the confidence interval is a tool to estimate your parameters based on collected data from your sample, which is a subset of your population. Then lastly, we will end the discussion here on your maximum likelihood estimation. So this is a formal derivation of how your statistics were derived as estimators to estimate your parameters. Now for some definitions on your parameter versus statistics. So your parameter is a quantity that fully describes a distribution. So we also associate a parameter with describing or summarizing the whole population. So it's associated with the whole population and full distribution. Meanwhile, a statistic is a quantity that describes a sample of the population. Note that your sample is just a subset of your population. So, subset lang yung sample ng population. So, in practice, we rarely deal with whole population of subjects. Ang inobserve natin usually is a subset of the population or a sample of the population. And then from that sample of the population, you draw out and attempt to estimate your parametric quantities. So you are approximating your parametric quantities from your small sample or a subset of the population. So yung tawag dun sa mga traits that approximates the population are called estimators. So there are multiple ways to estimate your population parameters. So for example, you have your measures of central frequency, which you have discussed earlier in your high school. So yung median, mode, tsaka mean, it approximates or it attempts to describes the population from a small sample collected. So yan, so yun yung examples ng estimators. You now have some of examples of your estimators. So you have your normal distribution with mean mu. So your parameter that describes your population that is normally distributed is your population mean. And your estimator, given that you take a subset of your whole population of n subjects, is your sample mean given here. So yan. Ito yan. So yung sample mean. And then another parameter of your normal distribution is your population variance, sigma squared. And an estimator is your sample S squared given by this. This is your standard deviation of your sample. So this is given by the square of the difference of your individual measurement per subject minus the sample mean. And then another population is your Poisson distribution, population with Poisson distribution with rate parameter lambda. And then you have your population mean lambda as your parameter that describes the Poisson distribution. And you have your sample rate parameter given by your lambda caret or lambda hat given by 1 over n over, times the summation of x sub i's. So these are the average measurements, so which would estimate your rate parameter. And then another example of your population is a population with binomial distribution with n spaces and probability p for let's say a quantity that has two that is dichotomous. So with your probability of p with category 1 and 1 minus p with category 2. for a dichotomous setup. So you have your probability P that can describe your binomial distribution given with n spaces, and that your sample proportion given a subset of your whole population that is distributed in a binomial fashion is given by this. So proportion of success, number of successes over your total number of your sample. So that estimates the probability P of your binomial distribution with a very, very large N. We will now discuss interval estimation and confidence interval. So basically, given your sample, so let's say you have a very large population with size M. So let's say you get a sample with size N. So you are attempting to estimate a parameter that describes the whole population. So you get a small subset N. So given this small sample N, and doing some data analysis on this small subset with N subjects, what is the interval with which your parameter might be located with 1 minus alpha % confidence? So usually we associate yung percent confidence natin with the value of 95%. So I hope familiar kayo dun sa idea ng 95% na confidence interval. Okay, so this 95% confidence interval is also associated with this quantity alpha, which is your level of significance, which will be discussed later in hypothesis testing. So we have already discussed earlier that your sample mean, this is taken from a subset of your large population. So recall that your sample mean is normally distributed. So ibig sabihin ng normally distributed is this. So let's say you take another subset with number of subjects N, and another subset with population N. So you have three subsets na may number na members na letter N. Ayan, so meron kang 3 sample population. So assuming na meron kang 3 sample population. So ang sinasabi nito, class, is this. So take note, it's normally distributed with mean mu, and then take note yung one standard deviation away is this mu minus sigma over square root of n, and then yung one standard deviation to the right is mu plus sigma over square root of n. So ang sinasabi nito nung graph na to is that 68% of the time, yung probability, yung makukuha nyong sample mean would fall in this region. So it would fall between mu minus sigma over square root of n, mu plus sigma over square root of n. Yung sample mean magpo-fall dyan 68% of the time. Okay, yan yung ibig sabihin nitong relationship na to. Okay, so at 95% confidence interval, so you have this relationship. So bakit z of alpha over 2? Yung dinidiscuss natin. Take note that your z distribution or your z-score is symmetric with respect to your origin. So kung ang confidence interval natin ay 95%, ang level of significance natin alpha is 5% or 0.05. Okay, so we are evaluating this particular tail. So alpha, ito, 0.05. Ito yung alpha over 2 na probability. And then ito yung upper bound. So yung alpha 2 na region na ito. So dalawang tails. So meron kang 2 tails. Na ang area ay alpha over 2 and this is also another alpha over 2. So we are interested with the z-score associated with this particular area to the left na alpha over 2 and another z-score to the right na may area to the right na alpha over 2. So ito yan, we note this. So this, we label this as z alpha over 2 and this as negative z alpha over 2. So take note na pwede nating gawin yan na they are the negative of each other because your normal distribution is symmetric or an even function with respect to your mean. Okay, so we now have this relationship na yung probability that the z-score, ito class, this is your z-score. So you have your difference between your sample mean with your population mean over your standard deviation. So the ratio of the difference of your sample mean to the population mean with respect to your standard deviation is your associated z-score. So the z-score has 95% probability or 1 minus alpha probability of lying in this interval. So I hope this is clear. So we now derive our interval estimate with 1 minus alpha probability. So we use standard algebra. So you have now this negative z alpha 2 less than x minus mu sigma over square root of n less than z alpha 2. So multiply everything by sigma over square root of n. So we now have x bar or your population or sample mean minus your population mean to be between negative sigma square root of n z alpha 2 and between sigma over square root of n z alpha 2, and then we can add mu, we can change the direction of your inequality by multiplying by negative 1. So ano yung mangyayari dito class? So magiging negative sigma square root of n z alpha 2 mu minus x bar less than sigma over square root of n z alpha over 2. So now we now have our interval for our population mean. So it's x bar minus sigma square root of n z alpha 2 less than mu less than x bar plus sigma square root of n z alpha over 2. So we have this confidence interval from our mu. So take note, this is the 95% or the 1 minus alpha percent confidence interval given your calculated sample mean. So this is calculated from your sample. However, yung sigma natin dito, we assume that we know our population variance, but this is not the case. So itong estimated na ano natin na ng population mean, ang assumption natin dito is we know your population variance. Hindi yan yung case. So itong sigma na to is actually being estimated in your sample, which will be discussed in the next slide. So ito yun, I hope this is clear na we have estimated our mu. Now, we now consider the case of unknown population variance as I've discussed kanina. Alam natin yung population variance. So, kapag alam yung population variance, you have this confidence interval. Pero, kapag hindi natin alam yung population variance, we estimate that with your sample standard deviation given by this. So, yan, given by this, estimated by this. So, sa Excel, isang click lang yan sa dataset, makuha mo na yung sample, yung S-squared na yan, itong quantity na ito. So, we'll replace your sigma with your S. So, this is derived from your sample. So, yung ating interval estimation or confidence interval natin will be now given by this. And now, we replace it with yung sigma, we replace it with S. And we replace your Z-score with your T-score. So, T-score. So, note, yung T-score natin, yung T-distribution natin, has two variables associated with it to arrive at your T-score. So your T-score has your degree of freedom, nu, degree of freedom, and your alpha, your probability. Okay, so in this case, ang hinahanap natin ay yung T-score with degree of freedom n-1. So, kung meron tayong n na sample population, yung degree of freedom natin, df, is given by n-1. So, ang titingnan mo sa T-score table is yung value with degree of freedom n-1 at significance level of alpha over 2. So, take note, parehas din ng Z-score. Our T-distribution is symmetric with respect to your mean. So, kung ito yung T n minus 1 alpha over 2, same din yung value dito sa kabila. So yung left tail tsaka yung right tail symmetric. So parehas yung value. So this is your confidence interval. So yan. So in summary again, yung sigma palitan natin ng standard deviation no sample. And then papalitan natin yung Z-score ng T-score. And yung T-score, magmamatter yung degree of freedom, which is n-1 given your sample population n. So, yan. So, ito yung confidence interval. Now, here's the interval estimation for proportions. So, if you look at it, meron kang term na ganito, P times 1 minus P. If you recall, yung sigma squared, yung variance ng binomial distribution ay NPQ or NP times 1 minus P. Then in the derivation sa book, yung distribution yung ng standard deviation or sigma for proportion is given by this. Okay, so if you look at it, yung range o yung estimate or the estimate of our proportion is in this range. So P is in this range of P estimate. So this is from your sample minus Z alpha over 2 times the square root of P hat 1 minus P hat all over N 2 P hat plus Z1 half Z of alpha over 2 times square root of P hat 1 minus P hat all over N. Okay, so similar to other confidence interval, as N becomes very, very large, the confidence interval becomes smaller. Okay, so lumiliit yung confidence interval as your N becomes larger. Okay. Okay, for the Poisson process, if you recall in class, yung derivation natin, yung mean natin, mean is equal to your variance. Okay, so actually, your sigma here actually should be your yung sigma mo dyan should be your so substituted with your sample mean. So in this case, yung sample mean natin is replaced by lambda bar. So yung interval natin, yung confidence interval natin is given by this boundary. So yung confidence interval natin is given by this. So we have lambda minus Z alpha over 2 square root of all over N to lambda hat plus Z alpha over 2 okay, and then similar dun sa previous na mga confidence interval, as your N or yung sample number N natin, which is a subset of your large population big N, becomes very, very large, the confidence interval becomes narrower. Okay, ulit. So as N approaches infinity, Ci smaller or narrower. So essentially, you're getting a better estimate of your parameter that you want to estimate. We now estimate the difference between two means, ito mu x minus mu y. So if we collect data from a population subset na x and then population subset na y, so you have this statistic. So x hat minus y hat. Okay, note that yung kanyang yung mean ng difference, so the difference of the mean follows a normal distribution with this as with mu x minus mu y as your mean of the difference, so mean of difference, and the variance of the mean of the difference is given by this. So this is your related to your standard deviation. So kapag dalawa yung ano mo, yung variance mo, sigma x squared tsaka sigma y squared. So this is your parang ito yung standard deviation mo na counterpart, yung sigma counterpart kapag dalawa yung involved na quantities. So your interval estimated at alpha level of significance with probability 1 minus alpha is given by this. So, yan. So, may minus z alpha times this quantity. Parang ito yung similar to sigma over square root of n. So, meron kang minus, tsaka meron kang plus. Okay. So, ang important dito, class, if we are to establish that there is a significant difference, so if there is difference between mu x and mu y, or kung iba yung population ng mu x and mu y, so ibig sabihin, dapat, para sure tayo na may difference sila, or mataas yung likelihood na may difference sila, yung sa confidence interval, 0 is not included sa confidence interval natin. Kasi if you look at it, meron kang minus something. So this could make the left term or the lower bound a negative number and your upper bound a positive number. So if your confidence interval includes 0, then it's not right to say that the population difference between x and y is statistically significant. So now we continue. So yung sa kanina, so sa known sigma x and sigma y. So yung kanina, we know sigma x and sigma y. So may cases din na we do not know what is sigma x and sigma y, but we know that they are equal. And we also have a case in which meron tayong unknown sigma x and unknown sigma y, but we have an equal variances. So class, yung mga statistical software, they can automatically calculate the confidence interval depende do sa i-enter mong assumptions. But I just want you to look at the size of the interval. If you look at the book, page 180 to 81, gusto ko lang tingnan niyo yung size ng interval. So what happens? What do you think happens to the size of the confidence interval between this case and this case? So ano yung mas malaki yung confidence interval? Yung double star na case o yung single star? And then I want you to comment on that. So intuitively, why would one assumption have a larger confidence interval than the other? So take note, yung confidence interval is an estimate of your parameter. So the larger the confidence interval, so ganito class I hope this makes sense. So the larger the CI, the confidence interval, the less confident you are. Kasi malaki yung range of values na sinasabi mong pwede mag-land yung parameter. So the less confident you are. So the smaller the CI, the more confident you are of your estimate. So more confident of your estimates. So class, intuitively, without looking at the calculations, saan sa dalawang assumption yung nagbibigay ng mas malaking confidence, or kung mas malaking confidence, mas maliit na confidence interval? Saan sa dalawang case na to yung sa palagay nyo magbibigay ng malaking confidence interval and hence lower confidence in the estimation of your parameter? Note that this is now the interval estimation of difference of proportion. So note that the difference of proportion follows a normal distribution. Okay, so this is your distribution. So medyo kaya nyo nang makita, you can eyeball the estimates for your px to py, yung confidence interval. So this is px minus py minus z1 half z alpha over 2 times this term. Let's label this as letter A. Z alpha A 2 px minus py plus z alpha 2a. Okay? And then once again, if you look at it, same, similar trends. So if you have more values of nx and ny, the overall expression or the yung A natin is yung pseudo spread. You can think of that as the spread of your possible values. So the spread is smaller. So you would have a smaller confidence interval if you have more values of nx, larger values of nx and ny. Your variance can also be estimated. So your variance can also be estimated by this quantity q, which is given by n minus 1 s squared over sigma squared. So it follows a chi distribution with degree of freedom n minus 1. So take note, we are estimating sigma squared. So sigma squared is the one we are trying to estimate. S squared is your standard deviation of your S is your standard deviation of your sample. So S squared is the square of that. And n minus 1 is your degree of freedom, where n is yung n natin dyan is yung sample size. So the size of the sample. Okay, so your n minus 1 s squared over sigma squared can be represented by this variable q, and this variable q follows the chi-square distribution. So the probability of your q at a level of confidence of 1 minus alpha is given by this. So probability of chi-squared. So take note, your chi-squared function is is dependent on your degrees of freedom, n minus 1. So n minus 1 and then alpha over 2. Take note, class, unlike your t distribution and your normal distribution, your chi-square distribution is not symmetric. So you would look at the value of your chi-square distribution, in which yung probability, yung left tail probability is alpha over 2. And then you will look at the value of your chi-square distribution, in which your probability is 1 minus alpha over 2. So meron kang dalawang tails. So it's not symmetric. So para siyang ganyan for higher values of n. So ito yung left tail. So this is alpha over 2 yung area. Ito naman yung right tail. So take note, kung alpha over 2 ito, okay, so yung area ng cumulative no sa kabuuan is this one. The area of this is 1 minus alpha over 2. So you want yung corresponding chi values dito, chi values. So this is chi-squared values such that yung area cuts off an area of alpha over 2. This is yung left tail probability. And your right tail probability, yung area to the left is 1 minus alpha over 2. Okay, so yan. So ito yung this value is your chi-squared n minus 1 alpha over 2, whereas this value is your chi-squared n minus 1 minus alpha over 2. Okay, so yung area dito sa na green, itong area na to, this is 1 minus alpha. Okay, so if you look at it, this is q, then this q is equal to n minus 1 S squared over sigma squared. Then using algebra, you have this confidence interval for your variance. So kay class, so I want you to look at the asymmetry of your chi-square distribution. So it's usually that the case that itong value na to is larger than this particular value in blue, yung green. So pag tinignan nyo class yung chi-square distribution, usually mas malaki yung value nung chi-squared at alpha over 2 kaysa sa chi-squared at 1 minus alpha over 2. So what does that mean? So mas malaki yung denominator sa green dito sa left interval. So mas maliit yung value nito in comparison dun sa nasa right side ng interval. And take note class, your chi-square distribution function becomes flatter. So as flatter as the degrees of freedom increase. So tingnan nyo to class, nagiging flat yung mukha ng distribution as you increase the number of degrees of freedom. So what does that mean? So if it becomes flatter, the values of your denominator, itong denominator terms natin, lumalapit sa isa't isa. So kapag palapit yan ang palapit sa isa't isa, what would that mean? So kung palapit na ng palapit sa isa't isa, nag-a-approach palitan-palit yung interval kasi yung difference nila maliit. So ibig sabihin, yung interval mo paliit ng paliit. So as your degree of freedom becomes larger, the estimate for your variance becomes smaller, yung estimation interval, yung interval of estimation. So ibig sabihin, mas confident ka sa value ng variance mo. Okay, just looking at Turner, there's also an interval of estimation for ratio of variance. So this is given by this is from equation 7.86 in Turner. This is kay Turner. So class, hindi ko na siya i-discuss ng mabilisan, papakita ko na lang. So in this case, it follows the F distribution. So hindi na tayo masyado magde-dwell dito. So ang thing is, the ratio of the two variance has an interval, and the interval is bounded by these two parameters. Ito. Okay. So ang ano dito, ang nagma-matter dito class sa interval estimation sa ratio ng variance is this. So yung lower bound mo ba at saka yung upper bound, does that include 1? So for example, kung ang interval ng ratio mo is ng ratio ng dalawang variance ay 0.5 to 3.1. Ito yung 95% confidence interval versus 2 to 5.2. Okay, so suppose ito yung CI1. Ito yung CI2. So if you look at CI1 class, kasama sa CI1 yung value na 1. Includes 1 sa confidence interval. So it includes 1. Dito naman class, does not include 1. So nagmamatter lang dito is kung kasama or hindi kasama yung 1, yung pinakang critical na thing sa variance. Pag kasama yung 1, if it includes 1, we cannot conclude na yung variance or yung spread ng dalawang function or ng dalawang distribution is different from each other. We cannot conclude na different yung distribution, yung variance, yung spread ng distribution. But if 1 is not included, as in the case of your second confidence interval, okay, so kung 1 ay hindi kasama yung dito sa confidence interval, ibig sabihin, sure tayo na may difference doon sa variance. Mataas yung likelihood, super taas yung likelihood na magkaiba yung variance ng dalawang distribution. We will now end this lecture with this section on maximum likelihood estimation. So we are to create a likelihood function from your sample. So we create this likelihood function L with your samples x1, x2 to x sub n. So n yung numbers nila. So given your parameter p, what is the likelihood of selecting this sample x1 to x sub n? So we would like to maximize the likelihood function to estimate the parameter for consideration. So in this case, yung sa maximization natin, we obtain yung first derivative or yung partial derivative ng likelihood function with respect to the quantity that we are trying to maximize, p sub I. And then in the maximization process, partial derivative, kapag equal to 0, critical number siya. And then we take second order derivatives to determine if it's really a maximum. So kung yung function natin ay as a function of a single variable, dapat yung second derivative niya ay negative para yung concavity niya ay negative or opening down, so that sure tayo na meron kang local maxima. Pero kung yung function natin ay multivariable, we would look at the Hessian of the matrix. So we would look at yung second order derivative, so yung partial L with respect to second order derivative, yung second order derivative with respect to one variable, and then yung partial derivative niya with respect to the first, and then followed by the partial derivative with respect to the second. So meron kang Hessian matrix. And if your Hessian matrix is positive, may local minima ka. Kung negative, meron kang local maxima. So once you have your likelihood function and you have maximized it, and you have determined the condition that maximizes it, after you do that, yung previous step, you can now determine the estimator in the sample that highest likelihood of approaching or approximating our parameter. So, yung estimator natin, yun yung may highest likelihood of approaching a value towards our parameter. Okay, let's now first discuss yung maximum likelihood estimation. So we will work out yung normal distribution. This is a step on how we derive your maximum likelihood estimator by looking at your estimating your population mean and variance. So magkakaroon tayo ng guide sa steps, and then for proportion, we would attempt to estimate yung probability P. So we already showed this in the start of the lecture. So nasa earlier discussion siya yung may table. Okay, let's now proceed with your maximum likelihood estimation for our normal distribution. So kung normal yung distribution natin, so let's say you have in this normal distribution, you have your n values. Meron kang n values. So this is your sample population, x1, x2, x3, and so on until x to the n. So, ang tanong is, what is the estimator that best approximates your population mean mu, given your sample set x to xn, x1 to xn. So yan. So yan yung question. What is the estimator that best approximates your population mean mu given your sample set x1 to xn? So yan yung i-derive natin. Okay, so let us first derive our likelihood function given na hindi natin alam yung ating mean mu and variance sigma squared. So, hindi natin siya alam. So, let's first derive our likelihood function. So, let's write this. Let's spell this out. So, our likelihood function, I will erase this green part. So let's now write our likelihood function. So our likelihood function x1, x2, xn given our mean mu and variance sigma squared. Okay, so given our mu and sigma squared that we do not know, so not known, i-estimate natin ito. So given mu and sigma squared, our likelihood function is approximately given by this. 1 over square root of 2 pi times sigma e to the x1 minus mu negative squared over sigma. May 1/2 pa pala tayo dito, class. Minus 1/2. So, burahin ko lang to. Minus 1/2. So, this is your normal distribution. Okay, class. So, ito yung likelihood niya na mapili yung x1 times yung likelihood na mapili yung x2, 1 over square root of 2 pi sigma e to the minus 1/2 x2 minus mu naught squared over sigma. So, yan yung buong yan squared. And so on. Times and so on. We do this n times until x sub n. 1 over square root of 2 pi sigma e to the minus 1/2 x n minus mu all over sigma squared. So this is our likelihood function x1, x2, and so on, xn given our unknown parameters mu and sigma squared, assuming we have a normal distribution. Okay, so yung next step natin is we try to maximize our likelihood function. So we maximize this. However, one technique of maximizing our likelihood function is by taking the logarithm of your so you take the logarithm ln of your likelihood function, and then we instead maximize our log likelihood. So we maximize our log likelihood function instead of the likelihood function alone. We are now maximizing our log likelihood. So why does this make sense? So kung meron kang maximum value or may mataas na value for our likelihood function, yung ln nun maximum din, di ba? So hindi natin kailangan mag-work directly sa likelihood function. We can work with our log likelihood function. And besides, since we have a product ng probabilities because we assume independence of x1, x2, kaya pwede tayo mag-multiply. Kung naalala nyo pa sa class dati, we multiply if we assume na may independence between x1, x2, x3, and so on. So, meron tayong joint probability distribution function na product ng mga normal distribution for each of x1 to xn. So, yan. So, we have a product of n terms. If we take the logarithm of that, yung logarithm na yan would make it as a summation. Okay, so we now have this likelihood function, and now we will now take the log likelihood and then maximize our log likelihood function. Okay, so proceeding. Okay, note that your likelihood function that we have derived in the previous slide can be expressed as a product of multiple functions. So this is given by this. So you have your L, x1, x2, and so on, x sub n, given your normal distribution with parameters mu and sigma squared, is given by the product I from 1 to n of 1 over sigma square root of 2 pi e to the minus 1 half x sub I minus mu over sigma squared. So this is your your likelihood function as a product of PDFs or probability distribution functions of independent xi's. Okay, so if we want to maximize your L, computationally, it would be easier if we deal with the logarithm of this because this is a product function. So better kung kunin natin yung logarithm or yung ln. And doable naman yung pagkuha ng ln because yung kapag maximum yung function ng L, maximum din naman yung ln nung L na yon at that specific value kung saan siya maximum. So ulit, so if L is max at some value y, L and y is max at y. So the idea of maximizing L, so looking for the value of the set of variables that maximizes L, is similar din. So similar din yung makukuha mong value na magma-maximize nung L and L. Okay, so bakit natin gustong gawin yung L and L? Kasi yung property ng logarithm or ng ln function na yung logarithm ng product is the sum of logarithms. Okay, so let's now take the logarithm of your likelihood function. So we have now L and L is given by the summation, kasi summation na siya, ilolog natin siya yung buong expression. So summation from 1 to n ng logarithm ng 1 over sigma square root of 2 pi ang nagkakaroon ako ng ano dito na interchange ko siya. So gawin nating ln na lang para consistent. So ln kasi usually yung logarithm naman medyo understood yan na na ang base niyan ay e in most textbooks. So gawin na lang nating ln para consistent. So ln 1 over sigma square root of 2 pi minus, take note, ln ng expression ng e raised to something is yung argument no exponential. So the argument of your exponential. So this becomes 1 half x sub I minus mu over sigma squared. So yan na yung ating log or ln likelihood ng function. So we can maximize this by taking the derivative with respect to ln L. So if we want to obtain yung mu, an estimate for mu, we would want to maximize the likelihood function that best estimates mu. So we want an expression in terms of yung sample space natin, x sub 1 and so on, xn, that maximizes ln L, which in turn, since na-maximize natin siya, yung ln L, if ln L is maximized, L is also maximized. So yung likelihood function natin is also maximized. So as you've discussed in our calculus class, we take the derivative of ln L with respect to mu, so that you would find the value of mu that maximizes or minimizes yung likelihood function, and then later on you get the second derivative of mu, and then or kung multivariable siya, you get the partial derivatives, second order partial derivatives. Okay, so let's now obtain yung critical number. So let's now evaluate. So let's label this as star. So let's evaluate yung derivative ng ln L with respect to mu. So yung first term ng summation, since wala ka namang mu dyan, 0 yan. So this becomes summation of I from 1 to n. 0 yung first term. So yung second term na lang yung titingnan natin. So ang mangyayari is negative 1/2 times x sub I minus mu over sigma squared. So let's take the first derivative. So pag bumaba yung 2, magiging negative x sub I minus mu all over sigma times yung derivative ng loob, chain rule. So ano yung magiging sagot? Class. So magiging sagot ay negative 1 over sigma. So mawawala yung negative sign. So our first derivative with respect to mu is the summation of I from 1 to n times xi minus mu all over sigma squared. Okay, class, let's now solve for the critical value of mu that could maximize or minimize our function. So we now have partial of ln L with respect to mu equals 0. We have this maximizing or minimizing condition, yung critical number natin. So yung first derivative ay 0, and then later on we will check kung maxima siya or minima. So let's now solve this equation. So mangyayari dito is this. So this becomes summation from I from 1 to n of xi minus mu over sigma squared is equal to 0. Okay, kung equal siya sa 0, magiging, we can factor out sigma squared. So 1 over sigma squared, summation ng xi, I from 1 to n, minus, class kapag constant, take note, summation ng constant I from 1 to n, constant A is equal to NA. Ito class, yung second term, pag pinaghiwalay natin, mu over sigma squared. So this would become mu over sigma squared times n is equal to 0. So we can cancel sigma squared. So mangyayari class is summation from I from 1 to n xi 1 over n equals mu. Okay class, so we have shown that one of our critical numbers that could estimate or that could have a maximum likelihood for our population mean is given by our sample mean. Ito class, we have proven this using the maximum likelihood estimation method. So this is your sample mean. Okay class, it would be left as an exercise na i-prove ninyo class. So exercise na lang ito. So problem nyo ito sa bahay na show na maximum likelihood estimator yung mu na to, yung mu na ito. Show the maximum likelihood estimator yung mu na yan by obtaining yung second derivatives, which is will be discussed later on. So it's the maximum likelihood estimator. Ang na-show pa lang kasi natin ngayon so far is that the sample mean is a critical number. So pwedeng maximum siya, pwedeng minimum siya. So yun yung gagawin nyo sa bahay. I-show nyo na maximum siya. So that the sample mean is your maximum likelihood estimator. And since meron na tayong expression for our log likelihood function, which is your ln L, we can also take yung partial derivative niyan with respect to your variance squared and then equate it to 0 to obtain a maximum likelihood estimator for your variance. So pag ginawa nyo yan class, yung ginawa nyo yung condition na ito, makukompute nyo na estimator for sigma squared. Maximum likelihood estimator, i-show nyo din ito, is given by summation ng x minus x bar, which is your sample mean squared over n. So yan. So ito yung mako-compute ninyo na maximum likelihood estimator for your variance. So para ma-prove nyo na maximum yung mga yan, you will compute for the Hessian. So yung Hessian natin is given by this matrix. So this is your partial derivative of L with respect to m squared, partial derivative squared L, tapos partial mu, partial sigma squared, partial squared L, partial sigma squared, partial mu, second derivative partial squared sigma squared, o second derivative. So dahil ito yung Hessian matrix natin, so yung determinant niyan, so alam niyo naman yung determinant, so this minus this. So we would evaluate at the critical numbers, yung maximums, yung mga maxima niyan, yung value na ito, yung mu, you would evaluate your Hessian at this critical values, and then if the Hessian is negative, ibig sabihin maxima yung makompute ninyo. So it maximizes your likelihood function. So yun yung magiging assignment ninyo for the normal distribution. So I think nasa Turner din yung derivation nito or yung some steps in the derivation. But I want you to derive this on your own. So, i-check ko yung mga little steps kung tama yung pag-derive nyo at pag-prove na yung sample mean at saka itong maximum likelihood estimator ng variance ay maximum nga. They are the true maximum by looking at the Hessian. Okay, let's now compute your maximum likelihood estimator for your binomial distribution. So, yung binomial distribution, medyo useful siya sa atin. Kasi, meron kang dalawang cases. So, usually, sa random walk natin, sa binomial distribution, meron kang left-right, pwedeng up-down, heads-tails, or pwede ding with disease, or without disease. Okay? So given you have n participants or n subjects, so what the probability of having the disease is, let's say 0.2. Out of 100, what is the likelihood na ano yung value na estimator or estimate, pinakamataas na likelihood na number ng may disease. So parang ganon. So, we would now try to estimate the best estimator for our binomial distribution. Okay, for our binomial distribution, so B, it's described by these two parameters, yung n and your probability. Yung n natin is yung number of spaces, total number of your population, total number of your subject, etc. So actually class, technically, itong n na to, this is a very large number. So ang main parameter natin for the binomial distribution is your probability P. Okay, so we are trying to estimate your probability P. So given a collection of your sample population. Okay, so another thing class is na-compute na natin class yung expectation value ng binomial distribution given n spaces and probability of P of one of the categories. So na-compute na natin yan class. So your kung naalala nyo pa class, yung probability, yung expectation value ng position sa random, for example, so expectation ng n, so let's say n, yung n, small n, sorry. So yung expectation value ng small n is given by np, and yung variance ng n is equal to NPQ. Okay, so we have discussed this in class. We have computed this. Okay, so yeah, hindi ito parang yung normal distribution na kailangan mo ng dalawang parameters, which is yung mu and variance. Enough na yung probability P to describe the parameter of your binomial distribution. Okay, so P yung ini-estimate natin. So we will try to estimate P. Okay. So let's have a sample. Let's have a sample. So yung sample natin, class, let's say x1, x2, and so on, x sub n, where x sub I has two values. Yung x sub I natin, ang value niya is either 0 or 1 kasi it's either you, let's say kung may disease ka, 1. If you do not have the disease, 0. Okay? So let's now compute for our likelihood function. So ano yung likelihood function natin? x1, x2, and so on until x sub n given our probability p. So let's say yung p natin is associated with this case. So note. So yung probability natin, so if 0, if xi equals 0, ang probability natin is 1 minus p for this individual subject. Kapag x sub I equals 1, ang probability natin ay p. Okay, take note, we assume also that yung events sa x1 is independent sa x2, independent sa x3, and so on until independent sa x sub n. So we have multiple events in our n subjects. Okay, so same as yung ano natin kanina, yung ating exponential, yung normal distribution kanina, our likelihood function is a product of n functions. So let's spell out our likelihood function. This is given by pi product I from 1 to n. So ano yung itsura ng likelihood function natin? So it's p xi to the p to the xi times 1 minus p raised to 1 minus xi. Okay, let's look at this distribution, class. So individually. So let's examine yung kapag yung isa-isang term. So class, if xi is 0 or let's say x1 is 0, xi is 0, so kung 0 to, dapat q or 1 minus p. So p to the 0 is 1 and then 1 minus p to the 1. So it's now 1 times 1 minus p. Whereas kapag naman x sub I equals 1, p to the 1 times 1 minus p to the 1 minus 1, 1 minus p to the 1 minus 1, 1 minus p to the 0 is 0. So consistent siya dun sa definition natin. Okay, so this is our likelihood function. So like our previous example sa normal distribution, we take the ln of our likelihood function. Note that if we want to maximize our likelihood function, and then we try maximizing our ln of our likelihood function, yung critical numbers na makuha natin sa maximization ng LNL, parehas din sa makukuha natin sa likelihood function. So let's now obtain the minimization or the maximization for LNL. So let's evaluate first LNL. So ang LNL natin would become summation na ngayon. So summation I from 1 to n x sub I log p plus 1 minus xi log of 1 minus p. Okay, clear, class? Okay, sorry class, naguluhan ulit ako, class. So yung log, force of habit lang. So it should be lnp ln of 1 minus p. So this is now our expression for LNL. So ulit, our LNL is equal to the summation of I from 1 to n xi ln p plus 1 minus xi ln of 1 minus p. Okay, so we now try maximizing this. So we look for our critical numbers. So we take the derivative of ln L with respect to p, and then we equate this to 0. Let's evaluate first yung partial of ln with respect to p. Okay, so this becomes summation of I from 1 to n ln p. Ito lang titingnan natin. So magiging xi over p plus ito 1 minus xi 1 over 1 minus p derivative times yung derivative nung nasa loob negative 1, so this would become negative. Okay, let's further simplify this. So i-combine na natin. So this becomes summation of I from 1 to infinity x sub I 1 minus p minus 1 minus x sub I p all over p times 1 minus p. Okay, mas maano pang algebra. Let's continue. xi yung numerator, xi minus pxi. Tapos ito sige, isa-isay na lang natin yung terms. Summation of I to n. So xi yung numerator minus pxi okay minus p plus pxi. So mawawala itong term na to all over p times 1 minus p. Okay, so class, ang mangyayari ngayon sa first derivative ng ln L with respect to p is given by this summation of I from 1 to n of x sub I minus p all over p times 1 minus p. So this is our first derivative. Okay, so we try maximizing this. So take note, we equate this to 0. So summation of I from 1 to n. Pwede nating ilabas yung p times 1 over p. So 1 over p times 1 minus p x sub I minus p is equal to 0. So this would be cancelled out. Kasi factor lang naman yan times 0 pag tinaas. So this would now be again constant yung p with respect, wala siyang index sub I. So ang mangyayari is I from 1 to n xi minus pn equals 0. Therefore p is equal to summation of xi from 1 to n over n. So this is the estimator for our probability. Ito yung may critical number for our estimator do sa probability. So I think you can show na maximum siya. So this can be done by taking the second derivative of this. So deriving this with respect to p further. And then pag nakita nyo na derive nyo na siya with respect to p, yung second derivative nyo is negative. So once you have shown that, ibig sabihin yung term na nandito maximizes our likelihood function, and since it maximizes our likelihood function, it is your maximum likelihood estimator. Okay, so let's now look at our, once again, our um, critical value. So ito yung critical value natin na na-compute from the maximization. So P, estimator natin, is equal to summation of xi over n, I from 1 to n. Okay, so let's now look at our second derivative with respect to P of our ln likelihood. So, second derivative ng ln likelihood is equal to the derivative of our likelihood ln P, yung kanina, yung kinumpute natin. So, derivative nito, summation ng x sub I minus P all over P times 1 minus P, i-multiply na natin, so magiging P minus P squared. I from 1 to n. So take note, itong yung derivative, pag pinasok natin sa summation, so magiging derivative ng quotient, so magiging summation ng I from 1 to n, low de high, P minus P squared, derivative ng high, negative 1, minus high de low, x1, x sub I minus P, minus high de low, so 1 minus 2P, kasi P is 1, minus P squared, 2P, over low. So, P minus P squared squared. So, yung denominator, dahil squared siya, it's always positive. So, positive definite yung denominator natin. So, yung numerator natin magiging summation I from 1 to n. So, minus P plus P squared minus x sub I minus P plus minus 2pxi plus 2p squared. All over P minus P squared squared. Okay, so minus P minus P, so mawawala itong minus P na ito. P squared minus 2P squared, so that is equal to negative P squared. Minus 2px I, so magiging minus P squared plus 2px sub I, tapos minus x sub I. So ito yung expression natin, P minus P squared squared. So let's look at our summation. So summation of I from 1 to n of these terms minus P squared plus 2P x sub I minus x sub I all over P minus P squared squared. Okay, look at our denominator. Yung denominator natin, P minus P squared squared. So it's always positive in denominator, always positive. Okay, let's now look at our numerator. So, ang values natin ng xi dalawa. So, ang x sub I natin is either 0 or 1. So, in the case na 0 yung x sub I, so yung numerator natin would become negative p squared. So, negative of p squared is a negative value. So, we have now established na kapag 0, yung xi natin, negative yung value. Negative yung term sa loob ng summation. Now, if x sub I is valued at 1, so yung numerator natin ay magiging negative p squared plus 2p minus 1. So, this is equivalent to negative of p squared minus 2p plus 1, which is also equal to negative of p minus 1 squared. But this is always positive. P minus 1, quantity squared, is always positive. Therefore, kapag x sub I natin ay 1, negative din yung quantity. So, either kung 0 man yung value ng x sub I or 1, yung value sa summation mo is always negative. So, ano yung implication yan? So, yung second derivative ng ln L natin, whether yung xi's natin ay 0 or 1, yung second derivative is always negative. So, anong implication kapag always negative yung second derivative? Ibig sabihin, yung estimator natin na nakuha dito, yung p bar summation xi over n is a maximum. So, this is a maximum likelihood estimator. Okay, so this ends our lecture on chapter 7, K-Turner. So I will not discuss anymore yung moment generating function. So meron kayong assignment on maximum likelihood estimation, which is regarding dun sa Hessian ng normal distribution at yung pagkuha ng estimator ng variance ng normal distribution. So thank you very much. Okay, so reminder, meron kayong assignment which is yung sa maximum likelihood estimation, continuation and derivation for our normal distribution. Okay, so sige, thank you very much.